Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. This week on the podcast, we explore perspectives on trust in AI. In today's episode, we're joined by Parinaz Sobhani, Director of Machine Learning at Georgian Partners. In our conversation, Parinaz and I discuss some of the key issues falling under the trust umbrella, such as transparency, fairness, and accountability. We also explore some of the trust-related projects she and her team at Georgian are working on, as well as some of the interesting trust and privacy papers coming out of the NeurIPS conference. This week's series is sponsored by our friends at Georgian Partners. Georgian Partners is a venture capital firm that invests in growth stage business software companies in the US and Canada. Post-investment, Georgian works closely with portfolio companies to accelerate adoption of key technologies, including machine learning and differential privacy. To learn more about Georgian, visit twimlai.com/Georgian. And now, on to the show. All right, everyone. I am in Montreal, and I've got the pleasure of being with Parinaz Sobhani. Parinaz is the Director of Machine Learning at Georgian Partners. Parinaz, welcome to This Week in Machine Learning and AI.
Thank you, Sam. It's great to see you here and talk to you.
Absolutely. It's been a while since we've seen one another, and I'm looking forward to diving into the conversation. But before we do that, can you share a little bit about your background? How'd you start working on machine learning?
Long story.
It's always a long story.
I know, it's always a long story. I started working in AI and machine learning when I was in third year of my bachelor, and I joined the RoboCup team. I don't know if you know. Do you know what does it mean?
RoboCup. I just spoke to someone who also did RoboCup, and that was their kind of entree into ML and AI.
Oh, so cool! Yeah, exactly. So it's a kind of simulation for soccer. And back home in Iran, we all were big fan of soccer, and that's why we wanted to do something different, maybe simulation with robots, and then I really found it amazing. And then in my master, I worked also in machine learning. I worked on data stream classification and concept drift detection. And then I came to Canada to do my PhD. And I found one of the most challenging problems in AI is natural language understanding. If you look at the other problems that we are solving using machine learning technologies, speech recognition, vision and image kind of processing. I feel out of all, NLP and natural language understanding is one of the most difficult one. And it's mainly because over time, over the course of human evolution, natural languages has adopted all the kind of human complexities. So I feel that's going to be one of the last things that AI can achieve, truly. I mean, actual natural language understanding and generation, not simple mapping in sequence to sequence models. Yeah. Yeah. So, and then in my PhD, I worked on sentiment analysis and stance classification. And these are kind of baby steps towards natural language understanding, mainly text classification for social media. And then I worked for Microsoft Research, working on neural machine translation, and also for National Research Council of Canada, working on natural language understanding using deep neural networks, mostly tree-based LSTMs, DAG structure LSTMs, and stuff like this. And then...
Were you working at Microsoft Research kind of in the heyday of the neural machine translation when they were...
Exactly. That was Google started and they really wanted to have something similar, and they wanted to ship the product as soon as possible.
Okay.
Yeah, exactly.
Oh, wow. Exciting. And was a lot of that happening in Toronto?
No, in Seattle.
Oh, in Seattle?
Yeah, in Redmond, actually.
Okay.
I should say in Redmond. Yeah.
Okay.
The actual headquarters. Yeah. And then I joined Georgian Partners 2 years ago, which was kind of big decision because like nobody in my area, nobody in machine learning kind of community can think of like venture capital as a career path.
Right.
And I didn't know about a lot about venture capital as well, but I found the opportunity pretty unique. And the kind of opportunity that is like you're gonna have more exposure to multiple businesses and you can work with several different startups. Actually, at some point I decided I don't want to stay with big corporations.
Okay.
And I was so interested in a startup ecosystem, but I didn't know anything about startup ecosystem. So I thought it's going to be fun. I want to learn a lot. And actually I learned a lot. At the same time, it was more meaningful for me because I was helping startups that they didn't have resources or skills like the skills I had. And I felt, okay, Google has so many smart people, Microsoft has so many smart people. So let's work for some places or work on some problems that if I don't work on them, there is nobody else to work on them.
And so how did you get started working in the domain of trust and fairness in AI?
I guess like most of other machine learning scientists that are working on real world problems, in one of our projects, we realized, oh my God, it's such an important topic. And I actually realized I don't know anything about it. So I have focused a lot on the optimization and the choice of machine learning models, on like data processing, feature engineering, but I never thought about these kind of fundamental problems. And again, it's kind of interesting, at least for most of like products that I worked on, it's not full automation. It's more like a human in the loop that you provide recommendation and you have to build this trust with the human so that they will act based on your recommendations. And I felt, oh my God, even if I build the best model, if I can't build that trust by having better user interfaces or interpretability and showing the value over time and showing maybe like for some applications more critical decision making, it's also important to show the model is fair, then actually the product would not be adopted and all my efforts going to be useless. So that was the story. And again, it started by working with one of our companies, and I can't share a lot about the company and the project, but it was a pretty important automation for a pretty important decision making that could have impacted the individuals. And we realized that we never evaluated the performance of the model against fairness, against bias. And we started to think of like what would be the sensitive attributes for their problem. And looking at the literature, it was more about gender, ethnicity, but then we realized, no, it's not only limited to gender and ethnicity or religion. And for every application, we might have a different set of protected attributes that we have to consider. And then, so that was the fairness story. And then we decided, okay, how we can, let's first of all quantify the bias in the model. And we used a FAIR test. There is a kind of open source tool, which is great, very good user interface. And
what's it called?
FAIR test.
FAIR test?
Yes.
Okay.
I can't remember the authors of the paper. Can check, but I can't remember. Anyhow, but then, and we could kind of identify and quantify a couple of sources of the bias. And for their problem, we could solve this issue by having a better sampling strategy. So as soon as we identified what are the kind of underrepresentatives in these data sets, then it wasn't only a single iteration, it was several kind of back and forth, testing the model, improving the strategy, sampling the strategy, and then testing it again.
One of the things that you mentioned that came up in the context of trust was user interface, which is not something that, often comes up. What are when you think about kind of the broad, issues that fall under trust, what are the kind of main things that you're thinking about?
When I'm talking about trust, first of all, I'm thinking about transparency. And it's hard. And again, all these kinds of problems are hard to define, at least in a mathematical way. So by transparency, I mean, is it clear for the kind of users or customers how are you using their data, for what kind of processes you are using their data, and how the data has been shared across several different kind of use cases or processes. And then interpretability, explainability is really, really important. And again, like I remember 2 years ago when we were talking about interpretability in machine learning community, everybody were like, why should we focus on interpretability? We should focus on improving the performance of our machine learning models. And exactly in one of the projects that we were working on, we realized the users are not looking for that single probability or prediction. They are asking for more evidences, and it can help them to combine the knowledge of the machine or models with their own knowledge and having smarter decisions. And so like there are several different reasons that we might need interpretability. That's one of them. There are lots of discussion if interpretability can help causality or identifying if the model is biased or for scientific purposes. So there are several different reasons that we might need interpretability. That was one of the examples that I encountered in my kind of experience. And privacy also is really important. Again, it's not a secret anymore that machine learning models, they can memorize data. And especially if you use sensitive data to build your machine learning models, these models can remember the training instances and can be reverse engineered to get access to those sensitive attributes of the customers or users. As we are using machine learning models for more kind of sensitive applications like healthcare, the importance of privacy is even higher and higher. Security is actually more important than any of this because it's actually the fundamental layer. If you don't have the secure kind of computation, or if you don't encrypt your data in transition or in rest, and if you have a data breach, nothing else gonna work. You know what I mean? You have lost the trust.
Right. So it sounds like a lot of these issues that we sometimes think of as disconnected issues are all kind of come together when it comes to creating a trustful relationship between the user of an AI system and the system itself.
Exactly. Yeah, exactly. And every day there are new issues. For example, adversarial attacks, they are new issues completely specific to machine learning models. And like AI safety, like now these days in NeurIPS again, I saw lots of interesting papers about adversarial attacks and AI safety. Before we weren't even aware of possible risks of using machine learning models.
Are there specific examples of projects that you can talk us through that, where you kind of explore these various issues?
I can for sure talk about differential privacy. We worked on several different differential privacy projects. And as you know, we try to have the message as you can create value by having more private machine learning and data mining approaches. As an example, you can convince user to share their data, and you can aggregate data across multiple customers, building better performing machine learning models. At the same time, you're going to have guarantees in terms of privacy of the users. So that's the kind of like one of the most kind of inspiring projects that I worked on, because again, it's not only about, these are the risks, and it's also about creating value. It's also about win-win, kind of like you're going to have private models, you shouldn't, and at the same time you don't need to sacrifice the performance of the machine learning model.
Okay.
That's the kind of issue we have also with fairness, because normally in fairness people believe that there should be a trade-off between accuracy and fairness, while I really don't believe that's the case. At least in our case, when we improved the kind of sampling strategy, we could improve both the performance of the model. At the same time, we could have root out the bias and kind of discrimination in the system.
So this example where you had to work with improving the sampling strategy, what was wrong with the model before you did that?
So like we didn't, again, like there are several different definitions for fairness.
Right.
So we were mostly looking at group fairness. So for protected groups or for microsegments of the population, there was a huge difference between the performance of the model. And that's why, like, I know like lots of people argue that should we have individual fairness or group fairness, but what we achieved by having better sampling strategy was group fairness for protected groups.
And so can you walk us through those different definitions of fairness? Like how are people thinking about this problem?
So like, again, like some people argue that even if you have group fairness, you might not have individual fairness. For example, me and you having the same qualifications for the application, for an application X, we might be discriminated. We might not get the same utility out of the machine learning models. But at the same time, the model might have a similar performance for the microsegments that we belong to. So that's a kind of, I guess, intuition behind group fairness versus individual fairness.
In a space like this where you mentioned that we don't have good definitions for this stuff in math. It's even like we don't have good definitions for this stuff in English, let alone math.
Right.
There's so many different ways to define all these things. How does one go about creating, charting a path through such a murky territory?
It's really difficult, and you're right. Every time I'm giving a talk about fairness, I'm asking, does anyone have a good definition for fairness? I'm really willing to listen and learn more about it. But still, there is no concrete kind of definition or metric. And again, we are talking about like we have to quantify the bias, but then we don't have any kind of metric that everybody agrees that's a metric that we have to use. It's not like F1 score that everyone uses in machine learning now. We need to have similar score. But it doesn't mean there is no research. I'm really encouraged that we are in the right direction. In the machine learning community, even again, last night I saw a couple of papers that they were talking about different metrics about for fairness in NeurIPS. So like, again, the community is in the right direction. We are thinking about these problems and the other kind of encouraging thing that is happening is that we are kind of engaging with other communities as well. So now in the conferences, every time I'm giving a talk, I saw a couple of people from legal domain, and they are kind of challenging me and asking me questions, and I learn a lot from them. Also, sociology, like there are also lots of people from sociology interested in these kinds of problems. So we are in the right path, but it's still a long way to go.
Yeah, I was at the exhibit floor here in NeurIPS earlier and was getting a demo of some project that IBM Research was working on, a Fairness 360 toolkit, I think is what they called it. And they were going through some examples, and they had like half a dozen different fairness metrics. Then they touched on this kind of group versus individual and some others. And then they had, several different, ways that this kit could help someone address these kinds of issues, just like statistically working with biases that might be in their data. But even with 6, they're like, and it's open. You can, other people could add their own. There are just so many different definitions and ways that you might want to approach this.
Yeah, that's right. One of my favorite papers this year in NeurIPS is my classifier discriminatory?
Okay.
It's a really good paper because it also talks about let's root out the bias and let's find where this bias is coming from. It's not enough maybe to play with the optimization function or objective function. It might be better to start trying different sampling strategies or even start capturing more information about the entities. For example, there might be a strong predictor that we are not using in our data. So it's kind of like, it's not only about optimization, it's not only about math, it's also about figuring out what is missing here. And I guess it was also in my practical experience more important than the math or the optimization part. We tried a couple of approaches in the literature, but none of them actually gave us a pretty good result.
So what do you mean by finding other predictors? I mean, I guess what I'm hearing is something that, any data scientist is always trying to do, find additional features or variables that might have predictive value. Are you getting at something different?
No, exactly. It's the same thing. Like that, you can if you can kind of figure out what are the holes in your system, and can I get access? And you're right. Every time we're asking more information, we are asking for more resources, time, and effort. And the question mark is it worth it to invest in kind of capturing more information and getting access to that data? And sometimes it's worth it if we kind of realize it has a huge impact both in the performance of the model and also on the bias and fairness issues we have.
One of the things that seems a bit paradoxical in this space is that I think I have the impression, this isn't particularly well informed, but my impression is that in a lot of highly regulated industries, take for example banking, they historically haven't collected information about these protected attributes because they don't want to be accused of using them to make decisions. And now we're talking about using statistical approaches that need that information. Have you run into that kind of thing?
Yeah, I was in the panel exactly with a couple of other people, VPs and leaders of those financial institutes, and I was kind of arguing and challenging them that I need access. As a data scientist, I need access to those protected attributes, and they were like, why should we give you access? And I know there might be lots of privacy issues as well. So I was actively thinking about, okay, what would be the solution? So if you don't want to give access to those protected attributes, at the same time, you want to give the data scientists the opportunity to test their models against different kind of biases. What would be the solution? And the simplest one I could find was having an API. So you don't access the data scientists to those attributes, but you can have an API that you can send your requests to a server, and you can get the answer. So that's kind of simple maybe kind of solutions. Maybe we need to do more research on what's the best kind of framework or process. But yeah, that's a kind of huge problem we have with the senior leaderships of the companies, that they are why do you need access? And it's hard to convince them. We don't want to use them to improve the performance of our models. We actually want to use them to test our models. And without having access to them, there is no way that we can test our models.
Is it an absolute requirement to be able to test against a particular kind of bias or bias against a particular attribute to have those attributes available as labels? Or are there other ways that you could infer that from your data or kind of explore from your data?
That's a very good question. So normally we need to define the protected attributes and then test the models over different microsegments based on these protected attributes or sensitive features. But there are always proxies in data that we know they are a kind of good proxies of, for example, even if we don't have access to gender, the other attributes might be very correlated with the gender.
Okay, which is part of the problem, right?
Exactly.
In some cases.
Which is that's exactly the problem. That 2 years ago when we were talking about bias and fairness, they were telling us, okay, just remove those sensitive attributes from your data. And we were like, okay, don't you know about correlations in features? But at the same time, we can leverage those kind of correlations if we don't have access to it. And in fact, for that project that I was talking about, we didn't have access to lots of information like this. So we used lots of proxies.
But you weren't necessarily able to even test your proxies against any kind of ground
You're right.
truth
We even don't know
it.
how accurate these proxies. Even the only possibility is just, for example, the address might be a proxy for ethnicity, right?
Sure.
So and then you can just on public data sets, you can kind of test the correlation between the address and ethnicity. That's a kind of possibility. But on your data set, yes, you can't do anything.
Yeah. All this is making me wonder if there's some kind of intersection between the differential privacy and fairness. Not, so setting aside the privacy uses for differential privacy, like, are there ways to, I don't know, maybe mixing up streams, but I talked to someone else who was working on kind of a cryptographic way to allow people to do testing against data or share data without giving them the data itself.
That's a very good idea.
Which is basically like this API idea that you had. It's the same basic thing. And so I don't know if the only thread between those two is
No, that's a very good point. And I believe 2 years ago in KDD, Cynthia DeWork, she also had a invited talk, and she talked about maybe we should use techniques similar to differential privacy for fairness. And she talked, okay, like in differential privacy, actually, if you think of like the kind of data we have as a kind of matrix, and in differential privacy, we want to mask a row in the matrix. So, which means like we want our models to not be sensitive to any single user information. But in kind of like when we talk about fairness, we want our models to be vertically insensitive to some features. So there are some commonalities. But I didn't see any actual research in this domain. It's a great opportunity for researchers to start working on kind of using techniques like differential privacy for fairness.
So you mentioned one paper that you were excited about here at NeurIPS. What was the name of that one again?
Is my classifier discriminatory?
And were there any other observations that jumped out at you from that presentation or from the paper?
It's still like, I guess the presentation gonna be tomorrow.
Okay.
And the poster maybe tomorrow, but a friend of mine, she just told me about this paper and found it pretty interesting. There was another paper that I ran into last night in the poster session, but I can't remember the title. Yeah, I can just Google it if you want.
No, that's fine. That's fine. When you're working with startups that are trying to bring a product to market, they're under all kinds of intense pressures to bring a product to market, to kind of satisfy customers. Like, how do they, or maybe how do you typically have to convince them to pay attention to this, or are they already thinking about it? And
depends. Like some companies, they have already some data scientists that they have thought about those problems. Some of them know, and we have to convince them. So what I found out is that people are normally more familiar with security bugs. And I normally kind of frame fairness or bias bugs as kind of unwanted association, but it's a bug as well. And it's similar to privacy and security bugs that they are so hard to identify. But the risks are also very similar. So the same risk of like data breach, what would be the risk? What's going to happen to the valuation of the company? It's going to be very similar kind of impact on your brand if your model proved to be like discriminatory or biased. So that's kind of how I frame it, and I try to convince people to think about the importance of these issues.
When you frame it like that on the security side and the security, bugs that lead to breaches, there are increasing amounts of hard data about the costs of, these kinds of breaches, and the implications from, leadership change perspective and businesses. Are there similar examples from a breach of fairness or a breach of trust perspective? Are you familiar with any?
Not in the startup ecosystem, honestly. For example, I guess we all know about the kind of blog post that was about Amazon recruiting software that they stopped using it.
This was for folks that may not have come across this, an article that I actually thought a lot of the headlines were disingenuous. It sounded like they were researching some, using some tool in HR, and they found the tool to be to have a bias against women in the hiring process, and they decided not to use the thing, which that sounds like what you're supposed to do.
Exactly. Yeah. If it wasn't the case, you wouldn't even hear about it.
Right. So there's that, and I guess the Netflix prize is the one that comes up. Well,
exactly.
Is that a bias? That's more privacy.
It was privacy. Yeah, it was privacy. They used simple de-identification and it failed.
Right.
For example, Google example also that lots of people use it. If I don't know if they fix it or not, but like I remember 6 months ago, if you search for images of CEO, it was all white male.
Right.
And it's a hard question. And it's a kind of question that even I feel machine learning or data scientists can't answer. It's a kind of question that you have to ask in the community of interdisciplinary researchers. Because actually, if you look at the statistics, what's the percentage of non-white male CEOs? And it's a kind of, if you do random sampling, what's the likelihood of having one of those kind of, for example, women CEOs? Because right now, but it's not about equality, it's more about equity, and like that's kind of like hard decisions. That's kind of, as a kind of scientist, you're working on this problem and you have a random sampling.
I would take that, kind of restate that as part of the challenge is that we want our models to reflect our values more so than the data that we have to work with to create the models.
Yeah.
And so a model may be performing, accurately relative to the data, but that's not necessarily what.
Yeah, it's just reflecting the data.
Right, which is reflective of many, many years of biases.
Exactly.
Right.
And that's why we need to have more awareness that the main assumption of any machine learning model is that future is going to be similar to the past. So for any reason, if we don't want future to be the same as past, then we shouldn't rely on data. And we shouldn't rely only on machine learning technologies.
So what should we rely on? Do we know yet?
No, I was in NeurIPS yesterday, there was a talk. Can I Google? I can't remember. There was a tutorial actually. NeurIPS tutorials. It was very interesting. Were you there for that?
No.
It was a very good one. And surprisingly, there were very, very few people in the room. So most of the tutorials, they were packed.
Okay.
But this one, very, very few people. And I was like, why? These are questions that we need to think about. And unfortunately, there are not so many people in our community in that room. So that was the sad part. But there was a tutorial on common pitfalls for studying the human side of machine learning. And they had very, very interesting points. So they were maybe explainability is not enough. Maybe it's not only about casting the fairness as optimization. We should also fix the process. They had lots of kind of interesting points. And one of the kind of interesting problems they point out was data are not the truth.
Okay.
So there are also we know that there are lots of noise in capturing the data, and even and we talk about a future the past problem we have with data or machine learning models, but even sometimes the data is not even reliable because there are so many kind of noise in recording the data. So but my problem with those kind of talks is that they don't talk about the solutions. And as a kind of practitioner, I'm always waiting for give me a solution. And it might not be a perfect solution, but it can be a starting point. And okay, we have a long way to go, but we have to start from somewhere.
How structured is kind of your solution approach when you're engaging with one of these portfolio companies that recognizes that there's an issue or that they don't want there to be an issue?
That's a very good point. So normally if they don't, sometimes they also are aware of possible problems with their data and the problem they are solving. But sometimes it's harder to convince them. So I ask them, can you give me the access to data and the predictions of your machine learning models, and then I run some tests. For example, I told you about this FAIR test that can gives you all the statistics about kind of performance of the model across different microsegments, and it's very different combinations of these protected and non-protected features. And then I come with some kind of proofs. Okay, these are my evidences that your model is biased. Okay. Then let's think of like let's think about the possible solutions. And if they are using any kind of sampling strategy, we would start with improving the sampling strategy. If you have lots of data and you're only using part of your data, how can we improve the model by leveraging better sampling strategies or like other parts of the data that you are not using?
Is the implication there that that problems are introduced by their sampling strategy, or they can use alternative sampling strategies to overcome problems that are already in their data?
Exactly. They can use alternative sampling strategies or iteratively try different sampling strategy, test the model in that FAIR test kind of framework, kind of evaluating and observing the result and having the second iteration. The other kind of solution is that if they are getting their labels, if they're having a supervised learning problem, getting the labels from the humans, and if they are using human annotators, how can you define strategies to minimize the human bias? So like I remember for my PhD, I used mechanical Turks to label my data. So we had all these kind of quality assurance techniques to make sure that we're getting kind of accurate labels from our annotators. So we can do similar things.
So like quorum types of approaches and that kind of thing?
Exactly.
Okay.
That's another one. The other one is like, for example, one of my other favorite papers is the paper by Rich Zemmel, which is about learning a representation for your data that captures as much as possible information, but at the same time masks all the sensitive attributes. So kind of having two competitive goals when you are learning representations for your entities. It might not be possible for some applications because like we don't have enough data to learn the actual representation. We are not using fancy deep neural networks. So like we have a couple of solutions, but still sometimes we are in a position that we don't know what can be the solution, and we start researching again.
So first step is playing with sampling strategies and seeing if we can solve it there. And then the next step is just diving in, and it sounds like it's a combination of, data science and research and subject matter expertise.
Exactly.
And it's, like other aspects of data science, it's kind of hard to pull these two apart.
Yeah, exactly. Like any other problem.
You've mentioned how a lot of this work is interdisciplinary. Are there specific disciplines that you kind of look to first when you're looking for practical approaches that you might be able to incorporate into solving a company's problem?
Normally, what I found really useful is engaging with the product managers.
Okay.
Because they are the product owners, because they have the best understanding of their user requirements and their addressable markets. So like even their model might be discriminatory because they are not serving part of the population. So it's not like cohort of the user might not be in their addressable market. So it's really good to have their insights before having any kind of further experiments or exploratory kind of analysis. So like I found like product people are the best people to talk to. But what is really missing is a kind of trust officer in our companies. So, and we tried we just started to think about these problems. Do we need a trust officer? And it's not about the person who can solve every problem, but it's a person that can collect all the information from different stakeholders.
Right.
And he's like the owner of building trust with their customers. And again, it's not going to be a single person. It should be education for the whole company. And even we suggested you should add another kind of metric in your performance evaluation. When you are evaluating your employees' performance, you should add the trust component or responsible innovation or responsible AI kind of metric when you're evaluating your employees' performance. It's not going to be a single person, but again, you should engage as many as possible people from the company and even outside of the company, because, for example, sociologists, like we normally don't have anybody with sociology background in our companies. So it's really important to engage those people if you have such question like the Google problem.
Right.
Yeah.
Yeah, that's interesting. I can see at larger companies, I wonder where this will end up living, right? You've got your, chief data officers that are responsible for, both kind of protecting and securing data, or, sometimes it's a CISO, chief information security officer, who owns that. A CDO might own kind of monetizing data or, the way that they manage it. But to your earlier point, a lot of the challenge and the risk for larger companies would fall under someone who owns the brand, right? Yeah, I guess it says that it needs to be something that companies think about at the highest levels and have dialogues about.
Exactly. Somebody that can have a decision power and is in all the decision-making discussions. Somebody in a leadership team like that, because you want to make sure that for every decision you make that can impact your users or customers, you have a person thinking about all these kinds of problems that might happen later when you're deploying your systems.
And so when you're kind of looking for research to incorporate into finding a solution to a given problem, is there anything unique about your approach to that in this space as opposed to trying to solve a vision problem using unique research, or is it kind of the same? Google.
Google.
Archive search or something.
That's a very good point. I try to not bias myself by reading only papers from machine learning community. So it's research, and I'm a scientist, and I have to dig into different kind of papers and articles and blog posts out there. But at the same time, I'm trying to read more papers from other disciplines as well. So that's the only thing I can. And also, I try to be active in the community and having lots of conversation with people with different backgrounds. It also helped me a lot. But I really don't have any good answer to your question. That is there any fundamental difference between this problem and any other kind of problem we are solving?
Right. Are there particular communities that you've found to be, very useful and under recognized, I guess, in terms of contributions to this type of work?
Under recognized. Again, ethics in AI is also hot, so
right. So that's less of a problem.
Exactly, it's harder to find.
Ago.
Exactly. It's now hot. Lots of people interested to work in this area. Lots of conferences, talks, events. Yeah, top of my mind, I have no example.
Any other things that you're looking forward to seeing here at NeurIPS on this particular topic?
I believe what is missing is that our community, at least historically, wasn't very welcoming for people with different backgrounds. So I told you that in my PhD I was working on NLP, and I believe I met lots of people with linguistic kind of backgrounds in NLP conferences, and it was more welcoming. So, but here, if you don't have math background, you kind of feel intimidated, so, and I don't know how we can encourage people with not necessarily machine learning background to join our community and also give us comments and challenge us and challenge our kind of mathematical optimization techniques. That's, I guess, what I'm feel is missing right now.
Yeah, and I guess that kind of underscores we are kind of starting to have this conversation often about the role of diversity, like on teams, and helping to create awareness of these kinds of issues and identify, to help an organization be open to understanding where these issues might lie. And it sounds like you're kind of underscoring that at the level of the community as well.
Exactly. Yeah, exactly. Also, you are right. In our teams, we also need to have more diverse kind of opinions. And again, when we talk about diversity, it's not only about ethnicity or gender. It's also about having people from different backgrounds.
Awesome. Well, Parinaz, thanks so much for taking the time to chat with me about this stuff. Super interesting stuff. And as always, wonderful to catch up with you.
It was a pleasure. And I also really enjoyed the chat. It was as simple as Chang told me.
Well, we had a good one on the topic of differential privacy, Chang and I would encourage folks who haven't listened to the former series on differential privacy, they should take a listen to that one because it's good stuff.
Perfect.
Thank you. Thank you. All right, everyone, that's our show for today. For more information on Parinaz or any of the topics covered in this show, visit twimlai.com/talk/208. Thanks once again to the good folks over at Georgian Partners for their sponsorship of this series. As always, thanks so much for listening, and catch you next time.